we filming? All right. Hello, Dr. Hannah. So here I have my father, Dr. David Carney, Sr., and I'm going to teach him a couple of the digestive organs in a turkey, but we're also going to be looking at a duck heart. So let's first start with this. This is a gizzard, and a gizzard is basically just a modified part of the esophagus, which is used for food storage. After that, here we have, this is a turkey gizzard, by the way. We also have the liver of a turkey, and the liver, pretty large, and it has a lot of functions just like humans, where it can emulsify fat, also used for absorption and distribution of nutrients to the rest of the body. Then talk about this duck heart, as you can see here. So can you see the lines, Dad, where the different parts of the heart, the chambers of the heart? Yeah. So just like humans, ducks and most birds have a 4-chambered heart. So we'll go through them real quick. Right here you can see this is the right atrium. See that? Then this is deoxygenated blood. Goes down to the right ventricle. Then it leaves up this way and goes to the lungs to pick up air, so it becomes oxygenated blood. Then it comes back down to the heart through the left atrium. You see it right there? Down to the left ventricle. And then it goes out to the rest of the body. So hopefully you can see some of those chambers right here, some of the different chambers of the heart. It's kind of hard to see, but right there. Does that make sense? So right now, the birds are cooking. Once the birds are done, we'll talk about the different muscle types and the differences between turkeys and ducks. All right, hi Dr. Hannah. So now that we learned some of the organs, now we're gonna learn about some of the muscles. Now this here is a duck. The turkey is still cooking. So this is my sister Kimmy. Almost stabbed you there. So Kimmy, we need to learn different types of muscles. We learned 3 types of muscles. 2 types of muscles we're going to talk about today. The one is slow oxidative muscles, and the second one is fast glycolytic. Slow oxidative muscles have a lot of myoglobin, which means they can store a lot of oxygen. So they have slow contraction, but they have really, really high endurance. So you can contract those muscles for a long period of time. Fast glycolytic muscles, also known as white or light fiber muscles, do not have as much myoglobin, so they can't store as much oxygen. Stop laughing at me. It's okay. They can't store as much oxygen, so they have a quick contraction, but they have very, very low endurance. So, looking at this beautiful duck here, which looks amazing, let's cut open the big breast muscle here.
Nice, a little too big for the duck.
Nice, a little too big. That's okay. Okay, so let's look at this muscle. Beautiful. Look at that. So do you see how this muscle is really, really, really dark? So this breast muscle is really, really dark. What type of muscle fiber do you think it would have? Fast glycolytic or slow oxidative?
Slow oxidative.
That's correct. Now, as we know, most turkeys have both what are light and dark meat. The breast muscle of a turkey is light meat. So what type of muscle fiber is that?
The fast glycolytic.
Correct. Now, in the legs of the duck, they are also dark, just like this breast muscle. And the legs of a turkey are dark as well. Now, and that type of muscle fiber, as you said, is slow oxidative. The reason that a turkey has fast glycolytic breast muscles and slow oxidative leg muscles is that they can't fly, so they don't use their wings for long periods of time. But they walk for long periods of time, so that's why they have slow oxidative leg muscles. Ducks, on the other hand, fly as well as walk and swim. So both of their muscle groups in the breast and the legs are used for long periods of time, which makes sense why we see dark muscles in both the breast and legs. Now, a bonus question I'm going to ask you is, what type of muscle fibers would you find in the breast and legs of a bird that lives in the sea, such as a gull or an albatross?
Okay, so the fast ones would be in the legs and the slow one would be in the breast.
That is correct. Now, once we're done eating, we'll talk about some of the bones in the 2 different muscles. All right, hi Dr. Hannah. This is my cousin Chelsea Gregley, and I'm going to introduce and show her some of the bones of the bird now that we've eaten lots of really, really good turkey. So, first thing we're going to talk about is, this is called the furculum, or more commonly known as the
wishbone.
The wishbone, that's right. So go ahead and pull that. Ready?
Look, this is not pulling.
It's not pulling. Oh, who got the bigger piece?
I don't know.
That's really even. I think you did.
Woo!
All right, move on. So, now, we'll go on to the bird here. Behind the furculum, which is also known as the lip bone, there's this really big bone here called the coracoid, and then this bone right here. So then behind that you have what's called the scapula. You can see that there, right? Big shoulder blade bone. So the main function of all all bones is basically for attachment of muscles, right? So this here is where the breasts would attach. So kind of goes like this. Does that make sense?
Yeah.
So this part here is called the sternum, and then this part here is called the keel, which is just a lower extension of the sternum, and this is where all of the breast muscles attach, right along here. Okay, got that? Good. So then we'll go over here to the rest of the bird. This is the big humerus. This is the big bone in the upper arm right here. See that? And then as you keep going down on the wing, you have these two bones, which are like our forearm. You have the radius and the ulna. So the ulna is always bigger than the radius. So which one do you think is the ulna? Yeah, that's exactly right. Very good. And then on the ulna, there's something called an olecranon process, which is basically just on the top. You kind of see it there. On the top there, it's a little bit of a jutting out towards the elbow of the ulna, which can be used for different things in a lot of different animals. So for birds, it's just used for flapping the wings. But you can see like armadillos have a really, really long olecranon process. It's like this long that they use for digging. Cats have a really small one like this, which they use for stability when they're jumping and landing, things like that. Okay, and then we'll go to this big bone. Yep, this way. Just like, there we go, that way. So this big bone is the femur, which is the big bone in your upper thigh, right? Just like a human. And then, yeah, it's this way. This is where the patella tendon would connect, right down the middle of the bone. And then there's the patella bone right there. Kind of looks like an arrowhead that you would find in a human, right? And then you have these two bulges on top, right? Obviously, this is where the hip socket would be for a human. These are called condyles, the big bulges in a femur bone. Okay, and that's pretty much it, right? Absolutely. Okay, now time for review. Ready?
Oh, good God.
What's this called?
Don't remember, but that's the keel.
That's the keel. Good. Yeah. Now how about this one? The big shoulder blade, huh?
Scapula.
Yeah, the scapula. Good. All right. So these are the two bones in the forearm.
The ulna and the radius.
Which one's which?
Ulna, because it's bigger.
Yeah. So this one is
the radius.
The radius. All right. What about the big bone in the upper arm?
Oh, the humerus.
Yeah, the humerus. Good. And we just went over this one.
Femur.
Yeah. Good.
Yes.
Nice job.